Hello friends, welcome you in Research News. Today in this video we are going to see OECD 425 guidelines, acute oral toxicity study up and down procedure, UDP. More in this video we will see outline of OECD 425 and limit test, main test, how to use the software, how to install its explanation and some important considerable point to conduct OECD 425. The concept of the up and down test approach was first described by Dixon and Mode, and in 1985, Bruce proposed to use up and down procedure for the determination of acute toxicity of chemicals. It is not only used in chemicals, nowadays it is used also for plant products, pesticides, cosmetics, various things. Nowadays this method is used, and a study comparing the result obtaining UTP, the convenient LD50 test, was published in 1995, and the test procedure described in these guidelines is of value of minimizing the number of animals required to estimate the acute oral toxicity of a chemical, in addition to the estimation of LD50 confidence interval, and the test allows the observation of sign of toxicity. Actually, main purpose to conduct this experiment OECD 425 is to categorize the chemicals or product whatever available for calculation of LD50 and reducing the number of animals for the animal welfare purpose. By this method, we can use lowest number of animals. Even in 423, we are using per dose level 3 animals. But in 425, we are using only 1. Sometimes it needs 2 or 3. For to determination of LD50, the point of LD50, exact dose of LD50 we can determine by this method only. So in this method, we can observe a specific interval after between two doses, and also we can see the sign of toxicity while giving the doses. So this was the introduction, and in initial concentration, the testing laboratory should consider all available information on the test substance prior to conduct of this study. Before initiation of this study, we needed some data like identification of chemical structure of the test substance, physical chemical property, and results of any vitro in vivo toxicity test of the substance, available toxicological data, structure related substance or similar mixtures, or anticipated use of the substance. So because many times what happen while we are using any substance, and if you have not any information, that may be corrosive to animals, or that might have some other properties that create hampers or create problem during the conduct of the study. Sometimes what happen while you got the sample for toxicity study, while it dissolving in some vehicle, and you don't know its physiochemical property, it causing problem to dissolve in the vehicle, or the substance you have to use. Suppose you want to give those substance in water and it is not dissolving in water, so how you will do the experiment? So for that we need physiochemical property. For that many times we get the material safety data sheet we are getting, and in that we can get all these details generally. So we need some documents, means proof, before conducting any studies. many time what happen, you have a new substance, completely new substance. That time you are not going to establish all this data, but toxicological level you have to determine by this method. Means LD50 dose you can determine by this method. So this method mainly used for this criteria to determination of LD50. So this information is useful to determine the relevance of the test of the protection of the human health and the environment, and will help the selection of appropriate starting dose. So if you have previous toxicological study data or any documents that has shown it the substance character, so you can easily decide what dose we have to choose to start our experiment. So suppose your product LD50 is uh, around 200. So it is more convenient to use 175 mg, the starting dose. So the method permits estimation of LD50 with confidence interval, and the result allows the substance to rank and classified according to the globally harmonized system for the classification of chemicals which causes acute toxicity. It means by calculating LD50 by this method, we can decide the confidence interval level between two doses, and we can easily characterize our drug according to its physiochemical property. We can easily put in category, what class it is coming from, and how its toxic nature, that we can easily decide. Dose starting near 175 mg per kg and using half log units, dose progressive by factor 3.2. Doses will procedure best result. So in OECD 425, 175 mg per kg is a starting dose mainly we are selecting while conducting this study. So they have decided the criteria 175 mg you have to choose, and that dose you have to give to the animals. And after giving this, if you found the animal is surviving, so you can go further with in multiple application of 3.2 dose range. So 175 and next dose will be 550, and if the animal die, then you have to reduce accordingly. You have to divide 175 by 3.2, so you will get around 55 mg per kg. So that's way you have to decide what will be the next dose. So you have to give only one animal 175 mg dose, and then after that you have to wait for 48 hours, what and to you have to see what the symptoms or how the dose is doing with that animals, and what happens if animal die or surviving. This test substance of those that are known to cause marked pain and distress due to the corrosive severity not to be administered. So mainly the if the substance is corrosive or irritant, if the article is with you, then you have to do that. You have to do the experiment generally. But if the substance is already corrosive, you have to see how what will be the LD50. Then you already known what will be the LD50 dose. So accordingly you have to decide what dose we have to choose for this experiment. So in that case, when the substance is irritant or corrosive, the you have to check the MSDS or previously available data. In that data, you can easily get the what is the LD50 dose. Accordingly, you have to reduce the dose, and then you have to start the experiment. If the animals is in after dosing you found any morbid condition or it's showing some irritant behavior, distress, so you have to kill that animals. But before killing, you have to see if it is showing any suffering sign, then you have to kill in presence of, mainly we have to kill the animals in presence of veterinarian, or we have to ask them what happening with these animals, and then only we can kill. We have to sacrifice, and we have to collect their organ, and we have to send it for histopathological evaluation. And the method would not be practical to use considerably delay death. 5 days or more can be expected. So there is limitation in this method. If the considerably delay is observed, then there is no use, because after 5 days if animal die, we have decided we have already moved on second dose. So it will be very difficult to decide what happened, what will be the expected criteria. But we have to consider within 14 days, and accordingly we have to decide what will be the result and what will be the conclusion. Principle of limit test: 2000 and 5000 mg per kg. There is a one procedure is followed. In both cases, the general procedure is to dose one animal as the limit dose, whatever it may be, 2000 or 5000 mg per kg. If the animal dies, the LD50 is assumed to be the less than test dose, and the main test must be conducted to determine the LD50. If the animal survive, the additional animals are dosed, and the responses of the additional animals will be determined whether the LD50 is less than or greater than the limit dose. Principle of main test. Actually, if we have a substance and we have to conduct the experiment, so if you know the product is non-toxic, then we have to directly we have to conduct the limit test of 2000 or 5000 mg per kg, and we have to use that. We have to first give one animals, and then we have to wait for 48-hour interval. Then we have to dose second animal 2000 mg per kg, then third, and likewise sequence wise we have to give. Suppose first one animal, if it is getting die, then we have to stop. We have to reduce the dose, means up to uh, 3.2 times the dose for up to 550 around. And if it is not dying, so we have to go up to 3 dose, 2000, and up to 5 dose you can go, and you can stop the experiment. In case if you want to check out the 5000 dose, you can go more 3 times. If three times you have sequence wise you have given 5000 dose to animal, then you can go further up to 3 animals with same dose. And then if animals is not dying, then you can decide that your LD50 is more than 5000 mg per kg. And if on first dose or second dose it is dying, so we have to reduce the dose by dividing the dose 5000 by 3.2, and that will be around 1750 mg per kg. So next we will see in this procedure. This method is used mainly for the 2000 and 5000 mg per kg. It will be very helpful tool for the student who want to conduct their study and on the plant products or plant extract. So directly they have to give use 5 animals, and they can easily decide that 2000 mg is enough. More than 2000 is their LD50. So after this they can easily decide their doses. Otherwise they can go for 5000 mg per kg, and if animal not dying, 3 times they can give 5000 mg per kg, 3 animals, and they can easily decide that what their LD50 is more than 5000, and then they can start for the normal dose. Means they can go for pharmacological studies or for subacute studies. And next is the principle of main test. In principle of main test, the main test consists of single order dose progression in which animals are dosed one at a time and at a minimum 48 hours intervals. In main test, we have to follow simply the dose level of 175, 550, 2000 and 5000, or in between 2000 and 550 there is a 750 dose dose factor. As per 175, we have to go according to their dose progression factor 3.2, in multiplication of 3.2 dose progression factor, and we have to give one dose to one animal. Then we have to wait for 48 hours. If there is no death, then we can give the further dose, means like 550, or more than that 1750 around. So this is how we can go further. The first animals receive a dose step below the level of the best estimated of the LD50. If we are not deciding 175 mg, the first dose, in case we knowing that LD50 is lower than 175, then we have to choose the lowest dose than the 175. If the animals survive and dose for the next animal is increased by 3.2 times of the original dose. If it dies, the dose the next animal decreased by the similar dose progression. Each animal should be observed carefully for 48 hours before making a decision on whether how much to dose the next animals. And the decision is based on 48-hour survival pattern of all animals up to that time. The LD50 is calculated using the method of maximum likelihood. Description of the method. Selection of animal species. It's a mainly female rat animals we are using in this type of experiment. And if we are using male, we have to give some description about that, why we are using those. In case of some male preference drug, like some kind of drug that is used for the male animals, male human, and that kind of drug we are using in that kind of experiment, we are using male rats. Otherwise we have to use female, because females are more sensitive, preferred as a more sensitive for this experiment. In some cases, if the drug is more sensitive for male in male rats, we have to write that in a report and we can use the male rat. When toxicology, toxicokinetic properties, structure related chemicals are studied, the male are likely to be more sensitive. And the criteria for female, they should be nulliparous and non-pregnant and should be between 8 to 12 week old. Weight of 20% of initial mean weight. This plus or minus 20% is, we have to reject those while we are choosing animals for the experiment. We have to remove the animals whom weight is very than 20% less, plus or minus. The housing and feeding conditions: 22 ounce Celsius plus or minus 3, 50 to 60, no, not exceeding 70% humidity. Light should be artificial, the sequence being 12 hours light and 12 hours dark. The animals are housed individually. For feeding, conventional rodent laboratory diet may be used with an unlimited supply of drinking water. This is the normal general criteria. The preparation of animals. Animals are randomly selected, marked to permit individual identification and kept in their cage for at least 5 days prior to the dosing. Allow for acclimatization to laboratory condition. Ensure that animals are available in appropriate size and age range for the entire study. Preparation of dose. The test substance should be administered in constant volume by varying the concentration of the dosing preparation. In rodent, the volume should not be normally exceed 1 ml 100 grams of body weight, and however in case of aqueous solution 2 ml per 100 gram body weight can be considered. And for vehicle other than water, toxicological characters of the vehicle should be known. The administration of doses. The test substance is administered in single dose by the gavage using a stomach tube or suitable intubation cannula. Animals should be fasted prior to the dosing. Within the red, food but not water should be withheld overnight. With the mouse, food but not water should be withheld for 3 to 4 hours. Mainly for rats, we are uh, removing food from their cage for 12 hours. The animal should be weighed and the test substance administered and the dose is calculated according to the body weight. The after substance has been administered, food may be withheld for 3 to 4 hours in rats and 1 to 2 hours in mice. Limit test and pad test. The limit test is primarily used situation where the experiment has information indicating the test material is likely to be non-toxic. Already I have discussed those things, and there is a little or no information about its toxicity, in which case the material expected to be toxic. The main test should be performed. Yeah, that already we have decided. If it is plant material, we can use directly we can use limit test 200 2000 or 5000 mg per kg. And if it is, if we are not knowing that what is the substance, what is the means liquid, whatever it is, then we have to go for 175 mg per kg substance weight, and that dose we have to give first. Information about the toxicity test material can be gained from the knowledge and similar test compound and similar test mixture and product taking into consideration the identification of percentage of compounds. Limit test at 2000 mg per kg. The dose one animals at the test dose. If the animal dies, conduct the main test to determine the LD50. If the animal survived, dose 4 additional animals sequentially so that the total of 5 animals are tested. If their animals die, the limit test is terminated and the main test is performed. If an animal expected die later in the study and there are other survivor, it is appropriate to stop dosing and observe all animals to see if the other animals also die during the similar observation period. But in that condition, when the 48-hour duration is over, then what you will do? This is a questionable thing. So in that case, if after 2 or 3 animals are survived and then one animal is die, then the situation is bit means complicated. In that case, we have to see there are 3 criterias are given in that. Number of animals, 3 animals are survived, then we have to stop the experiment, or 5 reversal are completed, then we have to stop the animals, and lastly we have to see further what will be the result. The result are evaluated as follow: O is equal to survive, X is equal to death. LD50 is less than 2000 mg per kg when 3 or more animals die. 3 animals die, when then we can say that LD50 is less than 2000 mg in any condition. So here you can see it has represented here. It's showing that in second dose and here fourth and fifth animals dying. So you can say LD50 is less than 2000 mg per kg. If the third animals die, conduct the main test. If three animals constantly dying, then you can say one more animal. We have to conduct the main test from 175 mg, then according to the 3.2 progression factor. So test 5 animals. LD50 is greater than the test dose 2000 mg per kg when 3 or more animals survive. In that condition, if the 5 animals are survived, then we have to stop and we can decide the LD50 is more than 2000. If 2 animals die, then also we have to see. Here one animal is only dying, so they have decided LD50 is more than 2000. In below given all circumstances, LD50 is more than 2000. That we have to see. Next we will see we will test for 5000. They are following the same criteria. Those one animals at the test dose. Here what happened? Only three animals die can decide LD50 is less than 5000 mg. If animals more than three animals are not dying, then we can easily decide that LD50 is more than 5000 mg. So if the animal dies, conduct the main test and determine the LD50. If the animal survives, those two additional animals, if both animals survive, the LD50 is greater than the limit dose and test is terminated. And LD50 is less than the test when the three or more animals die. The LD50 is greater than the test dose 5000 mg per kg, then three or more animals survive. Now, main test is performed when little or no information is available about the product, it is toxic or not. The first animal receives a dose one step below the best estimate of LD50. The animal survives. The second animal receives a higher dose. If the first animal dies, the second animal receives a lower dose. This sequence is repeated until one of three stopping criteria is met. After recording the long-term outcomes for the animals, typically after 2 weeks, the LD50 estimate and confidence interval may calculated. The dose interval should be of 48 hours between two doses. In next point, while we are selecting LD50 dose or starting dose, then we have to start according to the literature available with us with that information. If it has given some already doses, we have to calculate a slope. If and according to that slope, we have to dose the lowest dose than the LD50. And we can conduct the experiment. If LD50 dose is already available, then what is the need of to conduct this study? We can we have to take those reference and we have to terminate the study. No need to conduct this study. If there is a compulsion to conduct the study as per the regulatory needs of that country, then we have to conduct the experiment with the lowest dose, a dose lower than the LD50 dose. A dose progression factor should remain constant throughout the testing, that is 3.2. When there is no information on the slope of the substance to be tested is available, then the dose progression factor always be 3.2 we have to use. And Using the default progression factor, dose would be selected from the sequence wise that is given here: 1.75, 5.5, 17.5, 55, 175, 550 to 2000. And the lower, as per the regulatory needs, it has not available of 2000, 1750. From 1750 to directly we have to go on dose of 5000. So this is the dose criteria while we are going for main test. Here it has given one example. One animal is given 1.75 mg. If animal survives, if animal dies, next animals receive the higher dose of 5.5 mg per kg. Here you can see animal dies, you can classify GSH category 1. The next animal, if animal survive, you have to give 5.5 mg per kg dose. If the animal survive, if animal die. Next, here dies, you can again categorize these animals as per classification of GSH. If the animals receive the higher doses, then we can go further. Test slope when one of the following stopping criteria first met. Three consecutive animals survive at the upper bound. If three animals surviving 175 mg dose we have given and the animals survived, then we go for 550 mg per kg. If again animals survive, then we will go for 1750. And if animals survive, we have to stop the experiment because three animals are survived at the upper bound. We have to conduct the limit test for 2000 and 5000. If regulatory guidelines permit, then we can go more than 2000. Otherwise, we have to conduct only 2000. Now we will see how to this experiment we can conduct by using software. So we will go on guidelines, the chart of A criteria. In that we will start our software. We will see the how they are conducting the experiment and what are the criteria and how to add the doses. So we are going to take first animals. In that it has already given 175 dose mg per kg dose we have to give, and we have to select enter. Then it will directly give the other dose. So we have to enter again here the second number of animals and 550 dose, and here it is showing duplicacy of the, so we have to correct A1 both places we have kept here, so we have to correct this A2, then it will give third dose, and directly third dose is it has recommended 2000. So according to software it has already recommended 2000, so we have to go for directly for 2000 dose, means it a part of limit test. So now it has again shown, we have shown that animal is not dying, so it is giving another option. Again you have to add 2000 dose. Again animal is not dying, so again we have to add next animal and dose 2000. Now animal is not dying, so it is suggesting stop the criteria. So this how we have to calculate this by the software. We can see here it is showing that our we are meeting our first criteria. Now we can print this. We can see the report also. It will directly show the report, and here it is given the report, and we have why we have stopped the experiment for further, that it has given in this report set. So this is how we can conduct the experiment by using software. So the software I have shown how to install and how to download, where you can get the software. in last of the video. Dose. So next, phi reversal occurs in 6 consecutive animal tests, and for phi reversal occurs in any 6 consecutive animal tests. For that, I have to show you the example by conducting those experiment in software. So I will show you software. Here you can see we have the OECD guidelines 425 and criteria B chart. So we have a software. In that software, again it's a main test, so we are going to take 175 in first. You can take less than that too. So here it's a first dose 175. Then we kept enter and it is showing animal is dying. So we are going less than that. So animal number 2 we have taken 55. In that it is showing after enter it is showing again death. So it is the same type of reversal, so we will go again less than that. So 17.5 our dose level should be. So here it is showing not die. So it is opposite than the previous result. So it's a first reversal. Here again we are going higher dose on 55 animal number 4, and in 55 it's showing again a death. So it is again a reversal because it is showing opposite than the previous result. So next we are going to less than that 17.5 again, and here again it's showing not die. So reversal again, opposite result than the previous. So it is one more of reversal, and again we will go on 55. Here again it is showing opposite effect, means one more reversal, and then we will go 17.5 again on animal number 7. Here 17.5, and we will see result, it is again opposite to the previous result. So it is showing 3 times we have conduct like that, so it is showing stop criteria, and it has software has given the LD50 dose level. Here it has opposite effect than the previous, that type of result it is given 5 times. So it is considered as 5 reversal criteria. So first time X, then X0, 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 like it has given the reversal. So it is called 5 reversal criteria. Now we will see the report. Here it has given the last, in second last line it is given, it has given the LD50 dose criteria, and it is showing criteria for 5 reversal criteria. So next we are going for, lastly we will see the last criteria. At least 4 animals have followed the first reversal and the specified likelihood ratio exceed the critical value. This again we are going to understand in guidelines how this criteria we can calculate by guideline chart. Guideline chart we can see stopping criteria C. Here we have uses various doses 175, then 550, animal not dying. Then we went for 1750, 550, and accordingly we have followed all the criteria. But lastly we closed on 5000 dose. Their animals is dying, and again 750 it is not, animal is not dying. In this criteria we have seen it has used around 4 reversal, and then our software suggesting, while we are using software it is suggesting mostly stopping criteria. In this condition, LD50 is not decided, so we have to rethink and start experiment again. If the animal unexpected dies late in the study and there are other survives at that dose or above, it is appropriate to stop dosing and observe all animals to see other animals will die during the similar observation period. If subsequent survive also die in and it appears that all dose level exceeded the LD50, it would be most appropriate to start the study again. Yeah, this is crucial point we have to see. We have to rethink and we have to conduct experiment again. If subsequent animals survive at or above the dose of the animal that dies, it is not necessary to extend the dose progression. In case when you have given dose 175 mg, if animal up to for 48 hours it was not died, and after 48 hours you have given the second dose and that animal is surviving up to 48 hours, and the previous one that to whom you given 175 mg per kg and that die, so you have to decide, you have to go further according to the dose progression factor. Don't look back, because the 550 mg per kg those animals is surviving. Observation: animals are observed individually at least once during first 30 minutes after dosing periodically during the first 24 hours and for 14 days. The first 2 hours are crucial while we are dosing animals and we are not knowing the what is the substance, what is the toxic level of the dose. So we have to observe up to first 2 hours. The the times at which sign of toxicity appears and disappears are recorded. The observations should be include changes in skin and fur, eyes and mucous membrane, respiratory, circulatory, autonomic and central nervous systems, motor activities, behavior patterns, tremors, convulsions, salivations, diarrhea, lethargy, sleep and coma. Animal found in morbid condition, animals showing severe pain and enduring sign of severe distress should be humanly killed and time of death should be recorded. Body weight. Individual weight are recorded before the test drug administration, weekly thereafter. Individual weight are recorded before the test drug administration and weekly and thereafter. At the end of the test, surviving animals are weighted and the humanly killed. So body weight we have to check weekly, means you have to check first on 0 day, then day 7 and day 14. At the end of the animals are weighted and humanly killed. While if any animals are about to die and or it is in morbid condition, then we have to first take the weight and then we have to kill it or sacrifice. Pathological animals included those in all animals including those which dies during the test or after removed of the study. Before should be subjected to cross necropsy and microscopical examination of organs showing evidence of gross pathology. Animals survive 24 hours or more hours after the initial dosing may also be considered. It means animals who survive up to more than 24 hours, then we have to subject it for then we have to consider it for necropsy. Otherwise we have to no need to do any necropsy. Data and reporting: all data should be summarized in tabular form, and for each test dose, number of animals used, number of animals displaying sign of toxicity, number of animals found dead during the test or killed for human main reason, and time of death of individual animals, description of the time course of toxic effect and reversibility, necropsy findings, calculation of LD50. LD50 is calculated using maximum likelihood method like written as follow, where L is likelihood of the experimental outcomes, mu and delta, and n the total number of animals tested. Li1 minus Fj1 is the first animal survived, or Li Fji if the animals die, where F cumulative standard normal distribution, Zi log di minus mu upon delta, and di dose given to the first animals, and di standard deviation in log unit of dose, usually 0.5. It's a kind of sigma, not delta. Estimation of LD50 available for this circumcision given below. If the upper bound dose ended test, then LD50 is reported to be above the upper bound. If the upper bound dose ended test, then the LD50 reported to be the upper bound. If all the dead animals have higher doses than all the live animals, then the LD50 is between doses for the live and the dead animals, which do not give exact value of the LD50. If the live and dead animals have only one dose in common and all other dead animals have the higher doses, all the other live animals lower doses, or vice versa, then LD50 equal to the common dose. Confidence interval. Computation of confidence intervals. Confidence intervals provide valuable information on reliability and utility of the main test that was conducted. The wide confidence interval indicates that there is a more uncertainty associated with the estimated LD50. The reliability of the estimated LD50 is low, and the usefulness of the estimated LD50 may be marginal. It means if the interval is more or less, in both conditions it is difficult to decide what LD50. Judging what is the LD50 is difficult. If the range is narrow, then we can easily decide what is the LD50. The narrow interval indicates that there is a relatively little uncertainty associated with the LD50, and the reliability of estimated LD50 is higher. The usefulness of LD50 is good. Okay, the means of that, if the main test were to be repeated, and the new estimated LD50 should be close to the original LD50, and both these estimates should be close to the true LD50. Test report must be include the following criteria: test substance, what is the substance physical nature, purity, relevant physical chemical property, identification including case number and vehicle, and justification of the choice of the vehicle if other than water, and test animal species, strain, mycological status of the animals if it is known, number of age, sex of animals including the appropriate rational use of the male or female instead of female, source, housing, condition, diet, everything we have to write in the report, and all the report that should be include these all criteria that are mandatory. And the test conditions for rational for initial dose level selection, dose progression factor for follow-up dose level, and details of the test substance formulation including details of the physical form of the material administered, detail of the administration of the test substance including dose volumes and times of the dosing, and time of the dosing mainly preferred in morning, and you can also dose within 24 hours how many doses you are given, that all considered for one dose level, and detail more than 24 hours if you have chosen any dose then that is not then that animal will be not accepted in the experiment. Detail of the food and water quality. Results: body weight changes, evaluation for responses, data, dose level for each animals showing sign of toxicity, including nature, severity, duration of the effect, and mortality. Individual weight of the animals at the end of the dosing, in the weekly intervals thereafter, and at the time of the death or sacrifice. The time course of the onset of sign toxicity and whether these were reversal for each animals. Necropsy finding, any histopathological finding for each animals if available. LD50 LD50 data and statistical treatment of the results. These are the progress slope. Below 175 we can choose any slope. If we are choosing any slope, and that slope should be up to 1 upon 0.5 to 2, that is the lowest slope selection criteria. So we have to choose at least 1 or 2 while we are conducting study. Or if the drug is more toxic, then we can choose slope 3, 4, 5, 6, 7, 8. The progression factor is always 3.2. Before installation of software, means we will learn how to install this AOT425 software. We will see why we are using this and what is the feature of this software. In this software, it is recommend what dose we have to choose for the next animals, and second, why when we have to stop the experiment, and lastly, what is the confidence interval level for LD50 dose. So what is the statistical significance of that dose level while we are calculating LD50. Now we will directly go inside researchersop.com. There in software option we will see here, by scrolling down you will see here in 30 number you will find AOT software, that you have to click, and you will find a interface of OECD guidelines. In that, scrolling down you have to search digit 425. In that, here you have to click, you will directly get the download option, and that in download option you will find the software. Here you will find a software setup, and that you have to install. While you click that, you will find a interface. In that you will find a path that you have to select. Unzip the first, you have to unzip the file, and then you will find. Then you go in C folder, and in C folder you have to paste, and you will find many files. In that you have to scroll down, and you have to scroll down completely. Then here you will find a setup, and like I am showing you, that you have to install again. You have to click it twice, then it will show it like this option. We have to click OK, and this we have to click. It will take time. You have to say yes. It will take around 5 minutes, I think. And after 5 minutes, you have to click OK. Okay, and then it will show some error. Oh, you have to click OK always, and cut the option. You have to go back, stop this, and it is already installed in the. You have to go start menu, and there you will find OAT 425. You have to click OK, and you will see the interface. It is showing error mainly while you are installing, but you have to say OK, and then it will be automatically installed, because it is a very older version, around 20 years old, so it take times to install. Here you have to write the test substance number or name. Then here you have to test a test, it is limit test or it is main test. Here you have to write the animal number, and again while you click selecting the dose level, it will go away. You have to write yourself the what is your dose level, and then you have to select by O and X, it is dying or it is dead. The animal is dead or dying. So we will see the criteria limit test here. Lastly, how to conduct the limit test. In that first animal we have given 2000 dose, and in animal 2 again we have given 2000 dose and it is not showing death. And lastly again is suggesting a next option. In animal 3 again we are going to give 2000 dose. Then we will see what happened after giving enter. If an animal is not dying, again it will ask for animal number 4. It is not dying, then again it will suggest for animal number 5. If it is again not dying, then it will suggest to stopping criteria, stop the experiment. Here you can see LD50 is above 2000, animal is not dying, so you can select another limit. So we can get the report. We have to choose the pass and save the, we have to see the report. We can easily see, and it will show what is the stopping criteria and what is the LD50 dose level. If it is above, it will show above 2000, and how many animals it has used, that all it will be show. Your report will show. So next we will go for limit test 5000. If you want to change your test substance, we will go for 5000 dose level. You have to say yes. Now we will go for new experiment. Here again we will go for limit test 5000. We will select that, and first animals first animal we will select, and then we have to write here 5000, and we have to give the result option. Then it will suggest the next dose level. Animal 2, again we will put 5000 here. We will copy this so it will be easily we can write here. Again we have to put the what is the result for it. It has given two options, for short action and for long time action. So both we have to write. 3 animals already not dying, then it is suggesting stopping criteria is only for 3 animals, means for three times dose. So it is suggesting now 5,000. The dose level is above 5,000. In this category, mostly food products are comes. So three times you have dosed and it is showing above 5,000. Then we have to after 3 animals it is suggesting dose level is above 5,000. So this is how we can conduct the experiment using software, means LD50 AOT software. Now we will see some important points. In this video, while I have represented the softwares, I have entered the short time outcome and long term outcome immediately. It is for the errorless representation only. Short term outcome we have to enter after 48 hours later, and for long term outcome we have to wait up to 14 days after first dose of after each dose of and after in animal dose we have to wait up to 14 days, then only we can enter the long term outcome. If we are not adding long term outcome after 14 days, it will not show perfect result. It will give error full result, and you will find in 2000 limit test dosing you will find that it has given the error full result if you are not adding the long term outcome result after 14 days you have to enter, then it will be give the maximum likelihood of LD50 outcome. So this thing you have to note. In second point, in some case if animal is dying after 48 hours, suppose after 72 hours, and you have given the next preferred dose, then you have to see three events of mortality or survival for that particular dose to stop the experiment further. In third point, in case you have given 5,003 doses in the experiment and the short outcome it's showing no death, and in long term outcome it's showing death. So your software has shown the result that LD50 is more than 5,000. Then you have to go for main test. In main test, you have to dose 3 consecutive doses, and their short outcome is not death. In that condition, you have to wait for long-term outcome of those doses for main test doses. So in that they are showing not death. Well, but in this condition, software will show the animal LD50 is more than 5,000. So this is kind of error full result, and in this case you have to perform again whole the experiment. So this point you have to note. Point. In fourth point, if you have given a dose and that dose three times giving same likely result, like animal surviving, it is surviving all three times, then you have to stop the experiment and calculate the LD50 on the basis of long term outcomes, and the software will show automatically the LD50. In this case, I want to discuss you one example. Suppose I have given a dose of 550 to one animal and the animal is surviving, then we have increases the dose as per the progression factor 3.2, the 1750, and again animal is dying here, then you will go for 550 again dose, and in that dose again animal is surviving, then you have to dose 1750 again, and here animal again dying, then you will go 550 dose again, and here animal surviving again, then you have to stop the experiment, and you will guess the LD50 is between 550 and 1750, and the software will automatically calculate the LD50 in between. In same condition, suppose you have given 1750 dose and animal is not dying, then this situation following three criteria. So you have to go for maximum dose 5000, and in that condition you have to observe that animal is dying or not, and if animal is dying, then again you have to go for 1750 dose. If animal again not dying, then you have to go 5000 dose, and there you will find animal is dying or not, and such criteria you have to follow up to 15 animals, then you have to stop the experiment. This is the criteria. In C criteria mainly, you have to follow five for yourself, or then you can stop the experiment, or otherwise any dose when you have completed three times same likely result, means same result, like animal is surviving or animal is dying, three times the same, then you can stop the experiment. The software will automatically calculate the LD50 dose. In final point, software, the upper bound limit is infinite. More than 20,000, it is considered as a greater than 20,000 is considered maximum dose in by the software, and the lower bound is 0.0001, means 3 times 0 after point is considered as the 0. So this is the limit for this software. And lastly, I want to tell you, I have covered many points in this video, but some points are still remain, and the mathematical points I have not discussed in this video. I will do that in next video, but for that I have some requirements. I need 50 likes and 50 comments, then only I will go further, because it takes lot of time, energy, and resources that all collectively give one such video. This much video is enough for student and for general scientific knowledge. And in mathematical calculation, there are some interesting parts also that I can discuss you, and I will suggest you more deeper in that, because there is some arithmetical calculations, and that give you a simple solution for calculation of acute toxicity study. So they are also very much easy and understanding too. And I want to remind you that I am always available on comments. You can comment me all your queries, and I will definitely reply you if I have available time and resources. Finally, thank you. Thank you for watching research. Thank you very much.